So the next section we're going to talk about is solving equations with variables on both sides. And in the textbook, this is section 1.3. So sometimes you may be required to solve equations with variables on both sides, like 2x plus 9 equals x minus 3. So we have x's on both sides of the equal sign. To solve a problem like this, you need to get your variables on one side of the equal sign, and then we can use inverse operations to solve. So our goal whenever we see variables on multiple sides of the equal sign is to find a way to get them on the same side. So luckily you get them on the same side and with the same strategies that we use to solve equations with inverse operations. So example 1, it says solving equations with variables on both sides. And our first example is 10 minus 4x equals negative 9x. So we want to find a way to get both of our variables on the same side. In order to do so, I can either find a way to move this negative 9x over, or I can find a way to move this negative 4x over. So I want to move this negative 4x over, because if I move the 9x, I'm not left with anything on this side of the equal sign. I'll just be left with 0, and sometimes we forget to put the 0 there, so it just makes a lot more mistakes that way. So I have 10 minus 4x equals negative 9x. If I want to move this negative 4x over, or if I want to undo it on the left side and move it over to the right side, I can use those inverse operations that we've been talking about for the past couple weeks to do so. So this is a minus 4x. So to undo the minus 4x on this left side of the equal sign, I can add 4x underneath it. And then whatever I do to one side of the equal sign, I also have to do to the other. So if I add 4x here, I also need to add 4x on the right side of the equal sign. So once I do that, I'm going to bring down this 10 because that didn't change. And then minus 4x and plus 4x, those undo each other. And then I need to remember to bring down my equal sign. And then negative 9x plus 4x. So negative 9 plus 4 would be negative 5. And then x. So now I have 10 equals negative 5x. So I have negative 5 times x, and now my variables are on the same side of the equal sign. So now I can kind of follow the same steps that we've been following for this last couple weeks. I can just think, what do I need to do in order to cancel out the operations that are being done to the x? So right now I have negative 5 being multiplied by x. To undo multiplying by negative 5, I'm going to divide both sides by negative 5. So 10 divided by negative 5, that's negative 2. And then negative 5 divided by negative 5, those undo each other. So we're just left with x on the right side of the equal sign. So we have x equals negative 2 as our solution. And then for example B, it's 8y minus 9 equals negative 3y plus 2. So I need to figure out a way to get my y's on the same side of the equal sign. So I can either move this 8y over, I can subtract 8y from both sides to cancel it out on this side, or I can move this 3y over, I can add 3y to both sides in order to cancel out the y on the right side. So I know most of us would prefer to work with positive numbers than negative numbers. If I subtract this 8y here, it'll definitely cancel it out on the left side, but if I subtract it from this side, I'll be left with a negative. So I think what I'm going to do is I'm going to add 3y to cancel it out on the right side. And then if I add 3y on the left side, I'll be left with a positive amount of y's also. So again, this is a negative 3y, so to cancel it out on the right side, I'm going to add 3y. So I'm going to do the same on the left side. And just make sure that you're paying attention to where you're lining it up, that if you're adding a y, or a 3y, you're lining it up with the other term that has a y also, because those are called like terms. So then 8y plus 3y, that's 11y. And then I can bring down this minus 9 because we haven't changed that yet. Bring down the equal sign, negative 3y plus 3y cancels out, and then also bring down that 2. So now I have 11y minus 9 equals positive 2. So now I have a two-step equation. So I have something being multiplied by y, and I have something being subtracted from y. So remember, when we have a two-step equation like this, we want to try to undo addition or subtraction first. Because if I tried to divide by 11 first, I'd have to divide everything by 11, and I would end up with a fraction or a decimal. So I'm going to undo the subtraction first. I'm going to undo subtracting by 9 by adding 9 to both sides. And then I'll bring down my 11y equals 2 plus 9, so that also equals 11. I'm going to rewrite this up here just because I ran out of room a little bit. So 11y equals 11. And then now I'm multiplying y by 11. So to undo multiplying by 11 and to isolate that y, I'm going to divide both sides by 11. So multiplying by 11 and dividing by 11 cancel out. So I'm just left with y by itself, which is our goal whenever we're solving, is to get the variable by itself. And then equals 11 divided by 11 is 1. And then for these 3 practice problems, this would be a good time to pause the video and work on these practice problems on your own, and then play the video once you're ready to check your answers. So for practice number 1a, so our equation is negative 2x equals 3x plus 10. Again, my goal is to get the x's on the same side of the equal sign. If I choose to move this negative 2x over, then there will be nothing left on that side of the equal sign. So you can do that, but you have to make sure you put a 0 there. I would recommend, though, just to avoid making those mistakes, to try to move this 3x over so that you have something on each side of the equal sign. So this is a positive 3x. So in order to cancel it out on the right side and move it to the left, I'm going to subtract 3x. And then whatever I do to the right side of the equal sign, I need to also do to the left side of the equal sign. So I'll subtract 3x here also. So negative 2x minus 3x. Whenever the signs are the same, like these are both like negative numbers, or we can think of this as like plus a negative 3x if we want to do that. We just have to add the two numbers together and keep the signs the same. So 2 plus 3 is 5, and then they were negative numbers. So negative 5x equals, bring down the equal sign, and then bring down the 10 also, 10. So then I have negative 5 times x equals 10. I want to get x by itself, so to undo multiplying by 5, I'm going to negative 5, I'm going to divide both sides by negative 5. And then negative 5, or multiply by negative 5 and divided by negative 5 cancel out. So I'm just left with x equals 10 divided by negative 5 is negative 2. And then for B, 3 minus 4x equals 18 plus x. So we want, again, our x's to be on the same side, and they're not right now. So I can add 4x to both sides to cancel it out on the left side here, or I can subtract x from both sides to cancel this x out. I think to avoid dealing with negatives, I'm going to add 4x to both sides. So I'm going to add 4x to the left side in order to undo this minus 4x of this negative 4x. And then whatever I do to the left side, I need to do to the right. So I'm going to add the 4x under the other x term. So once we do that, I can bring down my 3. And then negative 4x and positive 4x, or minus 4x and plus 4x cancel out. Bring down the equal sign. Bring down the 18. And then x plus 4x. So this is like 1x plus 4x, so that's 5x. And then now I have a two-step equation. So I have, if I'm trying to get x by itself, I have a number that's being multiplied by x and a number that's also being added. So I'm going to undo the addition first. In order to undo this positive 18, I'm going to subtract 18 from both sides. And then 3 minus 18. So that's either like 3 minus negative 18 or 3 minus 18 or 3 plus negative 18, depending on how you want to look at it. The signs are different. So this is a positive 3 and a negative 18. So I need to find the difference between these two numbers. So the difference between 18 and 3 is 15. And since 18 is the bigger absolute value and that's negative, this is going to be a negative 15. And then equals 18 minus 18 cancels out, and I'll bring down my 5x. So I have negative 15 equals 5x. I'm going to rewrite that right here a little bit. So negative 15 equals 5x. I'm multiplying x by 5. So in order to undo that, I'm going to divide x by 5. Or sorry, 5x by 5. So negative 15 divided by 5 is negative 3. Remember, a negative divided by a positive is a negative. And then 5x divided by 5 just leaves you with x. So we end up with x equals negative 3 as our solution. And then for example C, or practice C, 3x plus 2 equals negative 4x minus 1. So again, our goal is to get the x's on both sides. I can either subtract 3x here to cancel it out on the left, or I can subtract 4x here to cancel it out on the right. So I think I'm going to subtract 3x from both sides in order to cancel out the x's on the left. So minus 3x. And then on the right side of the equal sign, minus 3x underneath the other x term. So 3x minus 3x cancels out. I'm going to bring down that 2. 4x minus 3x, you're just left with 1x, or just x. And then I'm going to bring down this minus 1. And then now I just have a one-step equation. So I have a number being subtracted from x. So to get x by itself, I'm going to add that number to both sides. So I'm going to undo subtracting 1 by adding 1 to both sides. 2 plus 1 is 3 equals x. So our solution is x equals 3.